Hey ho diddly, let's do some more. Yeah, let's do some more. Welcome to part 2 of lesson 8.3. This video is optional. Okay, you don't have to watch this. Okay, the essential essence from the previous video, talking about slant asymptote, using polynomial long division to figure out the slant asymptote equation, and then graphing that thing. That's it. That's all you need to know for class. Okay. But, I thought I'd have some fun here and do a couple more problems. Literally just for fun, okay? Just for kicks, as they say. Yeah? So, let's do example 2. This is a more complicated function, so it's just more fun. Yeah? More complicated, more fun. Have you ever noticed that within the word function is the word fun? You see, it's in the name. It's a function, yes. Okay, so let's factor this guy. Ooh, how do I factor that? Ooh, it's a cubic quadrinomial. I think that requires grouping. Yes? Notice, okay, so if I've got this, right? This is equivalent to taking out, let's take x squared from the first pair. Let me explain what I'm doing here, right? We're doing a factor by grouping technique. Okay, that's what we're doing. Sorry, I'm getting ahead of him. I'm just so excited. I'm just so excited to do this problem. I'm doing factor by grouping on this quadrinomial because usually if you see 4 terms for a polynomial, whether it's cubic or whatever, you should always try grouping because you get 2 pairs, and so you can see what happens. So I'm going to pull out x squared as the GCF of the first pair. So this is x minus 2. And then we'll pull out a negative 1. That way it's x minus 2 in these parentheses, which gives me x squared minus 1 times x minus 2. Oh, but shoot, look at that. Hidden in there, a difference of squares identity. X squared minus 1 can be factored further. So that's the fully factored numerator. So in the numerator, I've got x plus 1, x minus 1, and x minus 2. In the denominator, looks like I can pull out a GCF of 4x, and what's left inside is x plus 2. I thought I wanted to make a hole with this one. Did I make a typo while doing this? Maybe. I don't know. Well, I guess even if I did make a typo, let's just roll with it. Yeah? Let's just analyze it regardless. So it looks like this one does not have any holes, so I say none. X-intercepts. Use the shortcut. Say set the numerator equal to 0. You will find that your x-intercepts are negative 1, 1, and 2. As points, yeah? Those are my 3 x-intercepts. Wow, look at that. Just look at that. 3 of them. Oh, my goodness. Oh boy. Those are a little tight together, aren't they? Maybe a different graph. Maybe a grid with more spacing would have been preferable. Oh, well, we'll continue. Let's find the y-intercept by plugging in 0. Well, that's not going to happen. Because if you plug in 0, you're going to divide by 0. You see 4 times 0 plus 2. That outcome comes up to 0, so nah. Nope, not any. No y-intercept. And that's because we have an asymptote at x equals 0 and an asymptote at negative 2. So let's draw those asymptotes. Here is 0. And here is negative 2. Wow, yikes. What is wrong with me? I should have picked like this grid I've chosen. It's so compact. I should have expanded it. I was going to do that. I was thinking maybe whatever. Okay. I'm sorry. I was really just having a mental conundrum. I said, do I stop the video and start over? But then I'd have to tell the function joke again, and then I just don't know if that would be as genuine as it was the first time. right? So whatever. We're just going to deal with this grid, yeah? Let's find the slant asymptote. So the slant asymptote is going to be found using polynomial long division. Boop. And I say 4x squared plus 8x. Oh, yikes. Who came up with this? Me? All right. 4x squared times 1/4 x. If I do that, that will match my x cubed. And 1/4 x times 8x, that's 2x squared. Wow, that's nice. Huh. Oh, neat. Okay. And then, what, is that it? No way. Is that it? No, stupid. No, it's not it, dummy. Because -2 minus 2 is -4. Haha, a classic blunder. Yes? I almost made a classic blunder right there. Okay, that's -1 because 4x squared times -1 is -4x squared. Minus 8x. Subtract gone. Double negative, that's 7x plus 12. And that will be my remainder for this quotient. Now, the slant asymptote is just this thing, yeah? It's y equals 1/4 x minus 1. So let's graph that. The y-intercept is -1, so that's right here. And the slope is 1/4. So up 1 over 1, 2, 3, 4. It's going to look like that. So I might need to angle the initial little mark I made a little bit better. Like something like that. Boop. Let's say up 1 over, up 1/4 right here. So I'm going to continue like this. Then down 1, back 4 is right here. Down 1, back 4 is right here. So I'll kind of connect that like so. And there is your asymptotes. Yeah, I really should have chose a bigger grid. I'm sorry. You're just going to have to deal with it, I guess. All right, number line time. Yeah. Ooh, sheesh. You got a lot of points to test here, guys. Because we got a vertical asymptote at -2. We got an x-intercept at -1. We got a vertical asymptote at 0. We got an x-intercept at 1. And we got an x-intercept at 2. Sheesh. Mr. Spake, what have you done? Please don't hand us to this on the test. I said, maybe for a bonus? I don't know. Okay. Let's test this. -3. Okay. I'm not going to read this out loud. You just figure out the signs with me, yeah? That'll be negative over negative. So that is negative. Okay. Let us now test, negative, not 2.5. How about negative 1.5? Because we have to test in between those. So that'll be negative, positive. And so that's going to be positive. So this will be positive. And then between 0 and 1, so 0.5. So we're going to say 0.5. That's positive, negative, positive, and positive. So that is positive. Okay. Still positive there. And then between 0 and 1. So, oops. I guess I tested, that's what I just tested, huh? I tested 0.5. So that one's positive. Let me erase that mistake. I wanted to test negative 0.5. So that is positive, negative, and positive. So those signs come out to negative. Okay, so it flips. And then between 1 and 2, Oh my God. 1.5. Positive, positive, a negative, positive, and what is that? Positive, so negative. Oh my God, it's just flipping signs back and forth. And then after 2, let's go 3. So that'll be positive, 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 positive. Okay, that's positive. Yeah. Cool. There it is. Also, if you've taken pre-cal, you probably could have figured out without testing all that, because you know that the degrees of all of these are 1. Haha, right? So you know it's going to fluctuate between positive, negative, all that. Because the only time it's going to bounce is if the degree's even, right? Right? Wink, wink. Okay. So negative, it's negative infinity before -2. That means the curve is down here, and it's going to come up, but then it's got to approach this this slant asymptote. So it's going to come around like this, like so. Then it starts from positive, so it's going to be up here. Come on down to the x-intercept, and then pass through the x-intercept and continue down. I want you to notice it does pass the vertical. You know what? I'm going to change this color so you can really see this, guys. Yeah? So you can really see my curve. Here you go. This is just for you, guys. This is for you. My fans, my friends. Okay. Got my curve continuing down there. And then after 0, it's positive. So it's coming up from here, continuing down to this point. And after 1, it's negative, so it's going to dip and then come back. And then it's positive after 2. Yeah. And so it just follows. And there it is, our lovely graph. Sorry, that kind of looks silly, doesn't it? Your math teacher says, show your work, and this is what you submit on your paper. I don't know, this kind of looks funny. But that's our guide, right? That's how we know how this graph looks like this, is just these little sign charts all over the place. So let's actually graph this. Let me see. 1, -2, -1, 2. Oh, can I remember that? Okay. What did I say? 1, -1. To say. Hold on. I don't have the best. Okay, -2, -1, 2. I'm repeating the coefficients to myself because obviously I know what the powers are. In the standard form. And then was this like 4x squared to what? What was this? Plus 8x. I'm sorry. I don't have it written on a sheet of paper in front of me. I just have to keep looking back and forth. Hey diddly, look at that. 1/4 x. Was it -1? Now that's a beaut right there. That is a beaut, as they say. See? Approaches that not horizontal, slant asymptote or oblique. And you can also see x equals, what did we say, 0? Yep, right there. And you can also see, was it -3 or, 2? Yeah. And that's it. There it is. Yeah, that's all the information. Our graph looks just like that. Isn't that awesome? Isn't that just so cool that you can figure out what this looks like without technology and just testing signs and stuff? I don't know. I think it's kind of cool and fun. I get a kick out of it. Okay, so that's that business. I'm going to take a big old eraser and do this because I'm going to rewrite all that later anyway. And I want to take a look at example 3. Now, by the way, I won't hand you something this challenging on the test, okay? Maybe we'll do it in class for practice. I'm not going to throw this on an exam. I think I'd just be a mean teacher at that point. It's okay. We'll have fun with it. We won't be tested on this, okay? Now that previous one, this guy, oh, yeah. Yeah, you better study that. All bets are off on that. You better know that one. But this is a lot, okay? Okay. And again, I just care that you get the basic concept, yeah? All right, example 3, and this one I'm going to have real fun with. Okay, ready. Let's factor the numerator. That is a difference of cubes, right? That's a cubed. Oops, I'm still on the fat marker. A cubed minus b cubed. So that is going to factor as x minus 1 times x squared plus 1x plus 1. Yeah, over 4x. Yeah, that's just 4x. I was like, how do I factor that? Dummy. It's good. Okay, wholes. Well, thank goodness I don't think I see any of those. So none. X-intercepts. Okay. All right. Let's see. Well, I know I'm going to have at 1, 0. But to figure out when this is 0, that's quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But that's imaginary, okay? So that's the only x-intercept I have, because what makes the numerator 0, I would have 2 more imaginary numbers. But I can't plot those on a real grid, on the real plane, so that's it. As far as the y-intercept, kind of like example 2, there is none, and that's because 4x in the bottom means my vertical asymptote is at x equals 0. So I'm going to draw a blue asymptote like this. I'll try to make the curve a little bit easier to see this time and not overload it with black. And now what we're going to do is find the curvilinear asymptote. Oh, this is going to be great. So oblique and slant asymptote, when you use the polynomial long division, your result is linear, right? I erased it all, so I guess you can't see it here. How about here? Or here, okay? Right here, right? Because the difference in the degrees, this degree was 2, this degree was 1, means that the highest degree of my quotient is going to be 1. So it's linear, meaning it's a line. But here, the highest degree on top is 3, or I shouldn't say highest degree, I should say highest exponent, means the degree is 3 on top and 1 on bottom. But that means if I use polynomial long division, I'm not going to get a linear this time. Okay. Notice that I'm putting these place values for x. Now, 4x times 1/4 x squared. Okay? Yeah, that's okay. That's cool. I was going to freak out, but I'm okay. I'm chilling. Is x cubed. Oh, okay. That's easy. Okay. Nope. Okay, and then what? That's a remainder? Oh, wow. Pfft, look at that. I'm not even sweating. Okay. So the curvilinear asymptote is a quadratic. Now we're going to still X out this. Okay, we don't care about the remainder, which means this is my curvilinear asymptote. Y equals 1/4 x squared. Now, I have to plot a dashed line parabola because that's the asymptote. Yeah, the asymptote is a parabola. It's not a line. So I'm going to make a quick little table here, x and y. I'm going to plug in some stuff. So negative 2 squared is 4. 4 times 1/4 is 1. Negative 1 squared times 1, that's just 1/4. 0 is 0. Okay, so I'll use symmetry to get this one. If I do 3 squared, nah, that's a fraction. I don't want that. 4 squared, though, so input of 4 yields an output of 4, because 4 squared is 16 times 1/4 is 4. Can I get away with 6? Oh, I can. 6 squared is 36 times 1/4 is 9. Okay, so I'm going to plot I'm not going to put like little points, but these are going to be like markers for my asymptote, which I'm going to do in blue. So 0, 0, that's where the vertex of that parabola is, right? And then 2, 1 is about here. And then 4, 4 is about here. And then 6, 9 is about here. Okay, so this gives me a good idea. And then I'll reflect it. So negative 2 right here. No, negative 4. Wait. It was 2, 1, and 4, 4. What am I doing? 4, 4, 2, 1. Okay, that looks better. So negative 4, 4, and negative 6, 9. Okay, so this gives me an idea of what it should look like. Okay, see how I've tried my best, of course, to sketch a parabola that's an asymptote. And now I will test on my number line. Now I only have an x-intercept and a vertical asymptote, so 1 and 0. So a little bit less than 0, negative 1. Let's test that. Negative 1 cubed is negative, minus 1 is negative over negative. So that's positive. So to the left of 0, it's positive. Let me do red for you. Okay, let me do red. Okay, red. Okay. And what's going to happen here is I'm going to go down towards that asymptote, and then I'm going to curve back towards it, like so. And it's going to follow that parabola's leg over there. Now I need it between 0 and 1, so I'll do a half. A half cubed minus 1, that'll be negative for sure over positive, which means that is negative. So it looks like it's going to come down from here and go towards the x-intercept, hitting the x-intercept. And I'm assuming it's just going to follow, but it should follow, so that it should come out to positive. If you do like 2 cubed, yeah, that's positive over positive, yeah. So it's going to be positive if you need me to put that there. And then it's going to follow this curve, like so. And there you go. That's the graph of our rational function. So if you really wanted to see it, if I erase, oh, I'm going to feel so bad for this. I'm going to erase the blue. Oh, no. What did you do? I'll zoom in so you can really see this. It's like a little comb. Come here. Remember, this is just for fun. We don't care about video length, right? We're just having a good time. We're just chilling. Oh. Ah. Stop that. Can I get it? Can I get it? Oh, good enough. And then we will erase down this way here. That's your graph. Yeah? That's what your graph looks like without those invisible lines guiding it. Isn't that goofy? Oh, it's so goofy. Look at it. X cubed minus 1 over 4x. Let's graph that in Desmos. X cubed minus 1 over 4x. Oops. 4x. Hey, ain't that what we graphed? That's exactly what we graphed. That's, oh, and look, if you look at 1/4 x squared, and you call that your asymptote. Look at that. It follows that asymptote perfectly. Look at that. Wow. And then it's got the vertical asymptote at 0, and then it's curving like this. Isn't that bananas? I don't know. I think it's cool. I think it's cool that these asymptotes that these functions approach can be curved and not just a straight line. I think that's really neat. Okay, I'm about to end the video, but I did want to say one last little piece. I did mention in part 1 that in this I would explain, why do you cross out the remainder? Okay, now we're Algebra 2 students, which means we don't really have the most experience with limits. And I'm not going to do a whole lesson on limits here, but humor me. Let's look at my original from part 1. X minus 1 minus 4 over x plus 2. So a limit is just kind of, I don't know. I don't think I want to explain that. I'm afraid I'm going to say something wrong. A limit is like, what are you approaching? What y value are you approaching as x goes to something? Maybe that, well, that's, yeah, okay. I'm babying it down, dumbing it down. So if you look at this, right, limit notation looks like this. What is the limit as x goes to 0? Where is it going? Yeah. So if x approaches infinity, if x is going up and up and up to infinity, well, this is infinity, right? And then that's minus 1. And then that's minus 4 over infinity plus 2. Now, by the way, you can't plug in infinity like it's a number, not really, but you can conceptually think about what it means, yeah? And if you look at 4 over infinity plus 2, well, infinity is an insanely big number, right? Not really. No, infinity is infinity. It's never ending. But if you want to make it concrete, you could think of it like a really big number. And if you're doing 4 over big boy, big number, then that's going to be close to 0. So the idea is with your asymptote, your slant asymptote, as you're going to infinity, right? Because it's end behavior, because it's how is the function behaving on the left and right ends, this piece of your quotient is essentially negligible. It's pretty much 0, right? Because the closer and closer you get to infinity, the less this actually has to do with anything. And so really the majority of that asymptote is determined by x minus 1. That's really what's describing the behavior of the graph, because this tiny little piece here, it's so small, it's pretty much nothing, yeah? Especially the further and further you get out. So that's why you're allowed to kind of just throw out the remainder. I hope I explained that okay. I don't know if some college professor who does research on limits and asymptotes or something is going to come in here and say, Mr. Spake, come on, that's false. So I hope that doesn't happen. But hey, who knows? Yeah. That's my understanding of it, as far as I know. Okay. So that little quote, that little remainder, it just doesn't matter because it goes to 0 as you go to infinity. Okay. That's the fun video. Hope you enjoyed this. I know I did. This was a fun little video to do. But these two problems, example 2 and 3, don't worry. That's not on our test, okay? Don't worry about it. So, all right, take care. I'll see you around, and I hope you enjoyed.